after a brief reflection on prediction mining, we are moving on to a new topic, cluster analysis. We have used one cluster analysis method before, k-means, and k-means is probably the most well-known and the easiest to use method. I think the easy to use also contributed to its well-known. Many people think of clustering, they think right away k-means. But as you're going to learn in chapter 10 that k-means is actually it's not the right method for majority of the situations. So chapter 10 is a very long chapter. It introduced many methods. I would like to actually take time to really analyze and work with you to describe the weakness and the strength of every method. If you wonder why there are so many methods for clustering analysis, this is because clustering analysis is just simply very challenging. The reason it is challenging because we don't actually have a lot of external information. You are given a multidimensional data set and you suspect that they are clusters, they're patterns in the data set. You don't have any labels, you don't have any further information. It's up to you to figure out whether they are patterns, whether those clusters actually is meaningful clusters. And as you're going to see in this chapter, any random examples, any data, if you give it to a clustering algorithm, it will produce clusters for you. So therefore, whether the clusters that's being produced is meaningful is highly questionable. And a lot of times when we think of clusters, we think of globular, those rounded areas, very dense, and those are the easiest case. And there are plenty of other situations, the clusters of different sizes, different shapes. Even within one data set, you have different density areas. Therefore, all those situations need to be accounted for somehow. That's why we have, there's lots of methods has been developed. So part one, we're going to cover the basics and the partitioning methods, hierarchical methods. This is this week. Next week, we're going to talk about evaluation of the clusterings after our cluster has been generated, whether they're any good. And we will continue to talk about new additional hierarchical methods and density-based methods. And into week 3, we're going to talk about grid-based methods. And in chapter 12, two methods were mentioned quite frequently, but without really very detailed explanation. So I included those here. Those are expectation maximization for mixture models and one-class support vector machines. We have studied support vector machines as a binary classifier, but it can also, a variation of support vector machines is developed to learn class descriptions. It has applications in outlier detection, which is the content of chapter 12. Okay, so early learning objectives. Yes, there are lots of cluster analysis methods, and I have summary slides towards the end of the third week that summarize the key characteristics and the weakness and the strengths of different methods. Hopefully that's going to be helpful for you to retain this lot of information that you need to know. And I have 3 additional items to really emphasize that clustering is not just to apply one clustering methods to your data and say, hey, that's it. No, you have to use different methods. Hopkins is one, And there's other methods that I'm going to introduce in our exercise to help you to evaluate the clustering tendency of a data set, whether the data set has clustering in it before you actually go ahead and try to discover the clusters. Elbow methods and silhouette coefficients are the ways that you can determine how many clusters that might be in your dataset, what is there. And lastly, when you have, in some situations, when you actually have labeled data, you very rarely, right? That there are situations that you want to um, compare you want to run clustering and then use the boat label to compare to see whether this clustering makes sense. So I actually recently have just an example like this. In my project, I do lots of biodiversity data analysis. So for specimens, biologists would describe the colors of different parts of this organism. And we're trying to study whether biologists using color labels consistently. If a color that this biologist call a red, the red that's used, the word red used by all biologists within this little group, maybe for roses, for example, is there consistency? So what we had done is to actually run first a clustering algorithm, see if the color clusters, and then compare this with the the biologist label that they actually used. We made very little progress because we are very puzzled. It feels like well, there are some bottom line consistency that the red is definitely different from pink. I mean, definitely different from green or brown. However, variety shades of red, reddish brown, purplish red, are they the same or different? So there are lots of questions to be solved, but I just want to give you an example that sometimes you do actually want to have clustering compared to gold standards. Okay, so that's my introduction to this chapter. And next, we're going to move on talking about um, to review variety of different kind of clusterings that you might see in the future data set you will be analyzing in your work or in your life.